Welcome to the Infill Podcast, where we interview the most interesting members of the 3D printing and maker communities, live and with audience participation. And now, here is your host, Jonathan Levy.
Oh, hey, that's me. Greetings, everyone. Welcome. I'm really excited to have you all here. We have an amazing guest for you guys today. I'm going to get into that in just a moment, but first let's start with one of my favorite segments that we do every show, which is What's Printing, Jonathan, brought to you by Octo Everywhere. It's the segment where we go ahead and look at all the cool stuff that I'm currently printing, and for some reason the title is not showing. There we go. Nope. This title. Nope. Oh man, my sponsor segments are always pretty funny, huh? Well, there's a link in the description, and here we go. All right, great. So Octo Everywhere, as you guys know, allows you to remotely access and control your printers from anywhere in the world. So it's always fun to just see what I'm printing, and spoiler alert for new projects. So you can see right now Bobcat, which is a Bamboo Lab printer. Yes, Octo Everywhere allows you to add AI failure detection, is printing some honeycomb storage wall stuff, even though the title says something different. And I'm much more excited about this one. Millipede, which is a belt printer. And yes, Octo Everywhere allows you to tunnel in and see the full interface of your printer. Millipede is printing multi-board panels, but the reason I'm really excited is it is printing recycled PLA that I made myself. And look how beautiful it is. So thanks to Octo Everywhere, and check out, you get a $25 free credit. Use my link in the description. Awesome product that, as you can see, I use all the time. On to today's guest, as you're now seeing. Today we're joined by Dr. Igor Gaspar of MyTechFun. He is an engineer, he is a doctor, he is a content creator, he is a teacher, he's also an entrepreneur. We have a lot of things in common, but let me tell you, poor scientific integrity is not one of them. That's only me. Dr. Igor, welcome. Thanks for tuning in.
Hello, Jonathan.
Really great to have you. So I want to get into many different things, and by the way, thank you for appearing in my recent video and kind of rating my work. I really appreciated it. But first, I want to hear a little bit about your background professionally, and also how you got into 3D printing. You're a mechanical engineer, so I imagine you've been 3D printing for quite some time before any of us were.
Not really. I'm in 3D printing maybe a little bit more than 5 years. On my previous workplace, I was working as in a big injection molding company. Between many other tasks, I did programming of big CNC milling machine, and I was missing that feeling that I designed something and then I can hold it in my hand after the production. And because now I'm working as a teacher on a university, and I was missing that feeling, and I wanted to buy some small CNC machine, but it was not for the flat actually. So I was looking around, and then basically 3D printing was the solution for even for the flat. So that's how I jumped in.
What was your first 3D printer?
Prusa Mark III.
Okay.
That was my first. I did quite research, and later, when I was doing some investigation, I saw that NS3 was much more popular, but the reason actually for Mark III that it has quite good specifications at that time. Don't forget, this was more than 5 years ago.
Right.
And yes, I was quite happy with it. Now it is replaced with the Mark IV, but I don't really use it so often now because I use faster Core X5 printers.
Yeah. So did you immediately fall in love with 3D printing, and how soon thereafter came the YouTube channel where you decided testing all these materials? Because for those who don't know, and you should definitely check out Igor's channel, he's very much known for testing materials, more than anything, testing different dryers, testing how materials behave, testing strengths of materials. How far along was it when that came into the picture?
First, I started the channel, everything. I have some Arduino projects, printing projects when I was designing Fusion 360 instructions. And then I noticed that basically I was missing. CNC Kitchen has a great channel about this kind of testings, but somehow in last few years he started to go a little bit different direction,
Mm-hmm.
probably more popular direction. But I was missing some informations, and basically I just started as my own fun, and I started sharing my research, and I noticed that they are quite popular,
Mm.
and actually that's how I collected most of my Patreon supporters. They like exactly this kind of videos.
Right.
Can I answer some questions? I can see some questions in the chat. Somebody asked if I would test Polymaker filaments. I just received from Polymaker big box all fiber on filaments. It arrived yesterday, I think. So yes, it will be tested soon. PET and PPS, that's right.
Awesome.
Mm, okay, I cannot see other questions from me.
Yeah, and I generally, I mean, you're feel free to ask the questions. I generally save them until I try to weave them in when we're on the right topic,
Okay,
but whatever you want. Just because I
okay.
know
I'm
when
I'm
I'm a
waiting the
guest, I
questions
get
from you.
massive ADD. But feel free. I love that you want to interact with the community. But don't feel obligated. It appears to me that you really enjoy doing the testing stuff. Like my takeaway from the video that you collaborated with me on was like, okay, this isn't my happy place and I'm not good at it. But it seems to me like you really enjoy like getting into the science and testing the materials. Is that energizes you, right? More than say, project videos or printer reviews.
Yes, there are several reasons. Familiar with these kind of things, of course, with the metal, but I'm using that experience for these plastics.
Mm-hmm.
And actually, the other thing is that some of my results and research I can integrate on my workplace because, as I mentioned, I work on university. It's a food engineering department, but I
Mm-hmm.
try to integrate to mix this to bring my hobby to connect my hobby and my workplace. So I try to investigate possibilities of using 3D printers, 3D printing in the food industry. Sometimes direct contact with the food, but sometimes you just need, I don't know, pipe holders or something like that. But for that, you have to know the mechanical properties of the material. So
Right.
yes, part of my work is actually integrated, and we are writing some articles and these kind of things.
That is interesting. I think I'd asked you this at one point, but I think there 3D printing content creators fall on a spectrum. There are the folks who, and by the way, content creators as a whole, there are the folks who dream of doing this full time, and then there are folks who are somewhere on the fence. Stefan for many years really loved his job and wanted to stay, and it was very hard for him to leave. And then there are the folks who love their job and YouTube is just a hobby. Where are you on that spectrum? Is this ever something you see yourself doing full time, or you just love teaching and working in industry so much that you never see yourself leaving?
No, I don't think I will do this full time, and that's right. That's why I have more than 435 videos, and only two are sponsored videos.
Wow.
And basically, the companies offer that they will sponsor. But basically, the even those are paid. Just they wanted the video now and not in 5 months because I'm really
Mm.
full. So yes, I'm. When I do some review, I really like to do it, but I will stop doing product reviews because it's starting to be too much.
Yeah. It's also
Uh,
kind of, and I've talked about this on the podcast a few times, it's kind of a lose-lose proposition, right? If you're not critical enough, the audience may not trust you and your authenticity. If you really love the product and it's great. I remember a lot of people when
mhm,
the X1 Carbon came out, they're like, oh, these people are shilling. It took like 2 years for
mhm,
people to be like, oh, I bought one. No, it's actually as good as the earlier reviewer said. And then if you're too critical,
mhm.
you burn bridges with the company, but also no one else will send you printers. It's like you can't win with reviews unless you're a dedicated review channel like Aurora Tech Channel, who's built up credibility as like, no matter what, I'm going to be very thorough.
Mm.
It's hard. It's a hard line to walk.
Well, okay, I'm a little bit easier position because I don't really care if they don't want to send me anymore the
True.
printers. For example, about the V400. I did a
Yeah.
review maybe 5 months ago or something like that, and then there is one video. Probably you saw it. Uh, Guy was talking about these sponsoring and can we
Yeah.
trust 3D printer reviews and
Yeah.
similar. And he was talking about it was about S1 that he
Mm-hmm.
uh, refused the contract actually. And after that, I was getting tons of comments that, oh, probably I'm sponsored for the V400 and similar. No, I'm not. And actually, they contacted me again for S1 Pro if I want to do the review. And my first thing was, okay, but I must have a free hands. So I will test the printer as it is, and I will just present it. And I already know that it's still not perfect because they are missing the opportunity to create a printer for technical filaments. It can print on 350 degrees Celsius. We have several filaments now which can print at this temperature.
Right.
But they're trying to focus on the speed, and they have the heater block above the nozzle, which has some CHT channels.
Right.
To melt the filament better. But it is still from brass.
Right.
Coated with nickel, but whatever. So what we see, if you print continuously carbon fiber filaments, it will be fast and everything, but by time those channels will wear out, and you will have a smaller flow. So this will be mentioned in the video, but I'm not sure if they will like it or not. But
it's tough, and like I certainly find like I'm a people pleaser. I want to get along with these people. I meet these people, especially when I flew to China. It made it even harder. You know, you meet people, you meet their families, and they're like, oh man, I want to be critical.
Yeah, they are not your friends. They are
right.
You shouldn't be your friends because you must be independent from them.
Right. Or just don't do reviews,
Yes, that's less and less. The hardest for the working were the 3D scanning companies. Creality, RevoPoint, they are so hard. They asked me to see the video before it's posted. I tell no, there is no possibility for that. But no, they just want to see if I have some technical errors, mention some, I don't know, inaccurate parameters or something like that. Okay, I gave them the link. They watched the video. Oh, can I remove from the video that I lost the tracking when I was scanning? I cannot. If I lost the tracking, it must be shown in the video because I'm not creating a marketing video. I'm just presenting the review. And since that, none of those companies wants to send me a 3D scanner, but that's fine from my side. I don't care.
Yeah, I found myself saying literally today to a brand, I was like, let me just please give you some advice, which is actually funny enough, like advice that I learned in a Burning Man event like 10 years ago and really helped me in life. So we'll go off topic from 3D printing, but I'll bring it back, which is I kind of realized like, from the ether, someone explained it to me and it just hit me like the more you try to influence someone's opinion of you, the worse that opinion will be. Meaning people who are confident in themselves, in their products, in their intelligence, don't worry about what people are going to say or think or do. And the minute you start worrying, it makes you look really insecure. And I said the same thing to this company. I was like, the minute you start sending me contracts with language which clearly you're trying to get around, explicitly saying you have to say positive things, but they say things like the creator will maintain a professional and positive light throughout the collaboration. I'm like, I'm professional. I'm not going to sign anything that says I'll be positive. I think this could have been done better and here's how. Change out positive for constructive. But I'm like, if you're going to try and sign me to say I'll maintain a positive light and speak favor of any of these words, right, which are not outright saying like only speak positively about our product, I already have a lesser opinion of you and your brand, and I think you and I both know like the leading brands in the industry don't do that. I won't name names, but like the leading brands that we all know, they make incredibly high quality products, just send you a printer and they just say, just tell us what you think. Put it in a video, tell us, we just want to hear your honest opinion. That's it. There's no contract. There's no anything. Now, contracts are important when there's embargoes and things like that. But that speaks to people who are confident in their product. So let me ask, you've tested a lot of materials. What are some surprising things? I know, by the way, folks should definitely check out your Patreon because you offer like really a lot of data to your supporters. But if you can give us some tidbits of like materials that were surprising, either positively surprising, negatively surprising? What are some of the strongest materials? What are the ones that you had no idea how weak they were?
Very positive experience I had nowadays with the PET-CF filaments.
Mm-hmm. Yep.
My first was from the Bamboo Lab. Then I tested the Siraya. It is very cheap, quite cheap. I mean, $50 per kilogram or something like that.
Right.
Then I have from Kiditech, and now I received from the Polymaker. And separately, there will be a video where I will compare these 4 PET filaments, PET-CF filaments in one video directly. But it was a really pleasant surprise because it has great mechanical properties, temperature-resistant material. Sometimes it needs annealing to get that high temperature resistance. But yes, it's really the only disadvantage is that it is quite brittle material. So if you are expecting some impacts in your projects, then you should avoid exactly this kind of, because in that case, some kind of nylon is better than the PET. But it's not so sensitive to moisture. It is like PETG, but not like nylon, for example.
Right.
PPA-CF is extremely strong filament, but it is also very expensive.
Wildly. Yeah.
Yes, so that's what and what I have in progress, because I know at least once or two times every second day I'm getting question whenever I test two-layer filament. I receive it and it is in the dryer. You cannot see the dryer, but it is in the dryer now. And when I finish this podcast, I will start with the printing of the test objects. I also got the test objects from the Z Polymers, from the company, but also from a German company who offered that if I pay the material fees, then they will print these test objects for me. That was before the Z Polymers sent me the test objects. So
very interesting.
Yeah.
Now, typically, there's some debate about this, right? Like, technically, carbon fiber it's an additive, it's a pollutant, it lowers layer strength. But at the same time, when we think of really, really strong filaments, we also think of some of the carbon filaments. And I'm wondering, I have my own theories about this, but I'd love to hear it from you directly. Like, I'm sure you've compared nylon versus carbon fiber nylon, or PETG versus carbon fiber PETG.
Actually,
what are the
I have
differences?
a separate video where I was talking about these things. And usually adding carbon fibers, these are small fibers, and they must be small because otherwise they will clog the nozzle. And some companies try to place a little bit bigger, and I several times I clog the nozzle when I use 0.4 millimeters. So pay attention for the data sheets. If it says 0.6 millimeter nozzle is recommended, then use that nozzle.
Right.
And usually they will add some stiffness, but only along the X and Y direction. In that direction, usually it makes it weaker. But recently, this was also a positive experience. For example, with the Tin Marie filament PETG-CF, also everyone PETG-CF filaments, it has greater layer adhesion. But until that, everything I tested, the layer adhesion was much weaker. Usually it will make the filament brittle, but also the final test object will make brittle. The brittle filament may be a problem, when you are using some printer which has quite long Teflon tube and it bends a lot. For example, Creality K1 Max, I think, or K1. It's extremely a lot of bending of the Teflon tube, and very often it breaks the filament inside.
Yeah. And someone just commented in the chat also, never use these CF filaments in the AMS because they're super abrasive and they'll destroy the PTFE tubes. But also, if they break, you're going to have a lot of fun fishing it out.
It's
I also get the impression that I don't get the impression. I'm pretty sure it's a fact that adding carbon fiber reduces warping on materials like nylon, which then paradoxically, even though they're weakening layer adhesion by adding a pollutant, because you're getting less warping and layers are going down correctly, you're also in another way strengthening the part and having it come out better, potentially even strengthening the layer adhesion just because the part isn't warping.
That's right. And carbon fibers, so it extremely helps with those filaments which tends to warp to polycarbonate or nylon, PET, but also it is very useful if you want to anneal the test objects. Something I promised that I will do, but I still had time for that. For example, the PLA. PLA is very strong material. What is
Right.
the biggest disadvantage of the PLA?
Heat resistance.
That's right. 50, 55 degrees Celsius. You forget it in a car on summer
Hmm.
day, it will deform, right? But if you anneal the PLA, it can resist to temperatures up to 150 degrees Celsius.
Wow.
The
And it's
problem is,
cheap.
yes, the problem is, so it will still be strong. Problem is that it will deform during this process.
Right.
Now, some filaments try to make this kind of PLA which will not warp or shrink so much. For example, from Azure film, we have this filament. I think from Form Futura also we have that Vulcano PLA, I think that's the name. It will not shrink so much, but the carbon fiber version theoretically should hold this because, for example, Prusament have that PC blend.
Right.
The carbon fiber PC blend, I can anneal it and it will not deform almost nothing. So it will still hold its shape. What is squared, it will stay squared and similar. PETG-CF also, we can anneal it. Absolutely no deformation during the annealing process. And I
Right.
want to try to anneal some PLA filament
Yeah.
too. It should be okay theoretically. I'm not sure about the layer adhesion, so this is always a weakness, but yes, they have a lot with the printability. If you want to anneal the test objects, stiffness along the XY, and sometimes with the temperature resistance, they raise a little bit.
Right.
I'm not sure
Right.
what happened with those latest with I mentioned where we have actually good layer adhesion. I tried to analyze it under the microscope. I noticed that those fibers are a little bit smaller, for example, and Timori
Yeah.
PETG carbon fiber, because we don't need sorry, we don't need big fibers here or
Right.
many fibers. I think we just need just to make that printability better, and it will not
Right.
make weaker the layer adhesion. And
Right.
in that case, we will have good filament.
I also had and yes, view at your own risk. Yes, you heard that correctly. Annealing PLA can increase its temperature stability to 150°C. I had an epiphany this week or last week, and it actually came out of necessity. So I did some tests about drying and strength, and I was forced to face the fact of how weak my favorite material is, which is matte PLA, specifically matte black as well, is like 10 times weaker in Z than regular PLA. So I was spinning that over, and then of course I ran out of all black PLA because during the holidays shipments were delayed and stuff like that. And then I looked on my shelf and I'd been saving all this PETG-CF, PETCF, ABS-CF. I'd been saving it for something that I needed the heat resistance. And I was like, wait a minute. I print all this PLA in matte because I don't want glare. The prices are coming down so much of the carbon fiber filaments. Like Sunlu is now making a PETG-CF that's $30 a kilo. I was like, I can justify just switching from a $22 roll of matte PLA to a $30 roll of PETG-CF, and I've just been printing PETG-CF and PETCF and ABS-CF, just kind of the lower end, not nylons, for everything that I normally would have done matte PLA, and it's stronger. It's dimensionally as accurate, if not more so. It has a nice texture, and in a lot of ways, I mean, PETG, I hate PETG, just raw PETG, but PETG-CF offers everything that PETG does not, right? It doesn't warp. It's significantly less resistant to, or at least the ones that I have, the high quality ones are less resistant to moisture absorption. So I've just been doing that lately. I mean, if you have a good nozzle and you can print carbon fiber filaments all day, they're not a luxury anymore like they once were.
Yes, somebody asked about process to anneal PLA and get those results. I have two videos about it. Search for the lazy annealing. That's one of the video, and the other is annealing in boiling water.
Oh, interesting. I didn't know you could do that. Doesn't it warp the part?
Yes, I tried that with a regular PLA. In both cases, I had warping, but the temperature resistance was significantly
Yeah.
improved, 150 degrees in both cases. The lazy, very quickly, the lazy annealing, basically, when you finish the printing, you crank up the temperature of the bed to 90 or 100 degrees Celsius and use some plate or something like that and cover the
Yeah.
objects
Yeah.
and leave it there 1 hour. And if the adhesion is good, especially if you use some glue stick or something like that, but you're now expert in the adhesives, in that case, the objects will stay there and you will have less warping.
Oh, that's interesting. But
That's
I
one of
mean,
the methods.
what's your opinion if you can? I know some people hate ABS and ASA, but if you can, wouldn't it just be better to print an ABS or an ASA or even a nylon rather than a PLA and then going through the process of annealing it?
You know what is my biggest problem with the ABS or AS? I could print everything. If I need some functional part, in most cases, I'm going with the PETG because it's easier for printing.
Okay.
But the biggest issue I have with the ABS and AS, it's not the smell, it's not the warping, because we can print it quite good on these closed and closed printers, but it's the shrinking.
Oh,
You will
interesting.
have approximately half percentage, if I remember, half percentage average of the shrinking. So if you need something which have to fit to some holes or whenever you fit in, you create dimensions in Fusion 360, accurate, and you print it and you measure it. Oh, it's smaller, half percentage.
Hold on, my
One
missus is.
percentage.
Do you want to make a guest appearance? She was gonna crawl so that you all don't see her. Ugh. There you go, darling. Okay, I'm back. But don't most slicers compensate for shrinking?
Theoretically, you can enlarge. No, they will not compensate it. So if you design a part which is, I don't know, 80 millimeter long, it will be printed 80 millimeter long, but it will shrink a little bit. So if you measure it later, you will see it is, I don't know, 79.5 or something like that.
Hold on, I'm
So
pulling up my slicer
the
because I was confident that there's a shrinkage setting, but I don't know how it works, obviously.
and the shrinking may be a little bit different, depend, is it depend on the structure of the shape, or are you use 100% thin film, or is it solid inside?
Right.
If you have some L shape, for example, it will shrink differently.
So check this out. At least in Orca, I don't know about Bamboo Slicer, but it has a setting for each filament: shrinkage XY, shrinkage Z. And the default for Bamboo ABS is 100% shrinkage XY and Z. Actually, it's the same for PAHT. It's all 100 on all of them. That's interesting.
So it gives you the possibility to change that if you want.
If you want, but it's not done for you.
Mm-hmm.
Let's take a quick moment here, speaking of things that are potentially hard to print, and talk about this episode's sponsor, which is PCBWay. For those of you who aren't able to print things like Telemer or PEEK, PCBWay can actually do that for you. They can also 3D print metal, aluminum, titanium, tool steel. They can do injection molding for you. They can do flexible or rigid PCBs. They can do CNC machining. They can do pretty much anything. I have never heard of an industrial process except maybe enriching uranium, which they cannot do for you. They do it all with great prices, fantastic service. And my favorite part is they have a real-life engineer go over your order before it sets out on its journey to make sure that there won't be any manufacturing issues. Link in the description. I highly recommend and use PCBWay for all my own projects, even though now I have a CNC and I need to figure out how to use that. Igor,
small correction, they cannot print with Tulomer filaments so far.
They
don't
can't?
have this. No, cannot. They cannot. They don't have these filaments so far in the offer.
No
But maybe if
kidding.
you send them the material, maybe they can print for you. But
I thought that they could. They have PEEK though, right?
yes, PEEK they have.
So what's so special about Tulomer that they can't print it?
They don't have it. It's $500 per kilogram spool.
So they just don't keep it.
And it's quite new. So even for me, it was quite hard to buy the filament. I wanted to buy the filament, but nobody wanted to ship to the Europe.
Yeah.
And finally, the Dynamism company I contacted, they can send with custom shipping if I pay, but basically the Z Polymers sent me directly. So I got the filament directly from the company.
Okay. Because someone had asked in the comments, they can print PEEK, you're right. They can print stainless steel, titanium, tool steel, nylon resin,
Yeah.
and then you can enter custom materials. I wonder what would happen if you entered Tulamer. Would they go out and source it for you?
I didn't know
Maybe.
about that.
Yeah.
I printed a twist drill from the tool steel.
Yeah.
By PCB from tool steel, and I was able to print to drill regular steel with that twist drill.
With a 3D printed tool steel. That's awesome.
3D printed twist drill could drill regular steel.
That's awesome.
Also,
I
I
have a
separate
part
video about that, but
as well that they made for me. They made screwdriver bits for me that are custom. And it's mind-blowing to me how strong it is, especially if you drop forge it. Like I forged it in oil, made it even stronger. There was something I wanted to ask you about materials before we leave that topic. What are some
carbon fiber
materials that have...
safety.
Sorry?
Carbon fiber safety.
We can talk about carbon fiber safety, but I don't want to do a spoiler for your upcoming video.
Okay.
Yeah, I'm excited for that. I've been waiting because you told me you're working on it. But are you going to cover it pretty in depth, the whole like safety and carbon in your skin thing?
First, there'll be a video a review of polycarbonate and carbon fiber polycarbonate. There, I will just slightly mention it, but because I have testing in the progress, I got some air monitors, from air gradient, and with this I can monitor the quality of the air. I also want to test the upper wind. I think that's from the IKEA, that air filter, if it helps, for example. But for this, I need a few more weeks.
Yeah.
So, yeah.
What's your take on the whole like carbon fiber getting in your skin thing?
It's the safety is very similar like in the woodworking industry. I analyze a lot of data sheets, and basically we have the same safety like in the wood industry. For example, for those who is working with these materials on daily basis, basically, yes, he should wear safety glasses, mask, gloves. But for example, I work with the wood, I know, once monthly or every 2 months maybe. I don't care about this, and I don't. Of course, I pay attention that if I cut something, I will not get in my eyes those flying particles. But same with the carbon fibers. I mean, if you have few in the skin, that's they will come out. I mean, you wouldn't rib wood, for example, against your skin,
Right.
And you shouldn't do it with the carbon fiber filament too.
Right. And I think it's important to note, like, yeah, if you can't sand these parts down, you should never, or at very least, wear a respirator.
If you do it in good ventilated space, I try to do this outside. If I have to drill,
right.
For example, I have a hole, but it is too small or something like that. If I have to extend it, then I try to do it outside, and I pay attention for direction of the wind, so I will not inhale it and similar.
Right.
Yes, but otherwise, if you just print it and
actually,
I will test one interesting filament. I already have these filaments, only I don't have time for it. I have some filaments. It's some kind of PPA variation.
Okay.
From Siraya, but it has the carbon fibers are inside, like in the core, so they're not outside. And since the printing is laminate, it has laminate flow. It will not go outside. It will stay inside.
Interesting.
And theoretically, we shouldn't see them outside. I will check under the microscope, but this is something for the future.
That's interesting. You reminded me, though, what my other question was, which is 3DX Tech sent me over a bunch of filament. Thank you, 3DX Tech. And they sent me the first time I've ever gotten, I think this isn't it. This is Easy PETG-CF. But they sent me, I've never had before, glass fiber material. So I have no experience with it. I have an email in my inbox from them with some explanation to my questions. But when and why would someone use, because I know you've tested so many filaments, why would someone use glass fiber as opposed to carbon fiber?
But for example, if you want to dry your filament in microwave, it will not catch flame if it
Right.
is glass fiber. Personal experience, you can see that in the
Right.
video.
And by the way, thank
Uh,
you for that video, because that was a life changer for my filament recycling. Like, you can trace from the moment I watched that video onward, my recycled filament actually became usable, because I thought 6 hours in the
mhm,
toaster oven was enough. No, it was not, even for PLA.
mhm,
And then just doing your protocol, which takes, 5 or 10 minutes on and off in the
mhm,
microwave, and all of a sudden my filament is good. So thank
mhm.
you. Sorry to interrupt you.
Yeah, so that's one thing. The other thing, it's not conductive. So maybe if you have some applications where it is important, and then I theoretically it should be less sensitive to moisture, because,
Okay.
for example, if you have the regular filament, but if you add the carbon fiber to it, it will be more sensitive to moisture. But it is not so sensitive. It is a glass fiber. And another thing, that glass is transparent and you can have different colors too,
Right.
because the carbon fibers are black, and even usually it's black, but even if the bamboo, for example, have some color, they have
Colored
some
carbon, yeah.
basic material, but it will be dark red, dark something.
Right.
But with the glass fiber, you can have more lighter colors, for example.
And in terms of performance, rigidity, strength, things like that, how does it compare?
Uh, Usually the carbon fibers will have a little bit better mechanical properties. I notice under the microscope, at least with those filaments where I have in the video, the carbon fiber and the glass fiber versions. Usually the glass fibers are slightly bigger, and probably
Okay.
because of this, they are more brittle materials. And
Mm,
usually they have a little bit weaker layer adhesion, but the difference is not really big. So if this is important, for example, to have, I don't know, nice red color or something like that, if it is
right.
available, then you can go with the glass fibers.
That's
But other
interesting.
mechanical properties are similar. By the
I'm
way,
also oh, sorry, go ahead.
mhm, I'm not sure if you can see those materials there. Those are 6 industrial filaments from 3DX Tech.
Oh, cool. Uh,
Oops,
I wonder if they sent the same ones to you as I'm
no,
testing.
no, they are printed on over 400 degrees Celsius.
Wow. What
Almost.
printer do you have that prints that?
I don't have. It was printed on Prusa Pro HT90. You
Awesome.
can print up to 500 degrees Celsius. The heated chamber up to 90. It's not print. It's printed by my supporter,
Wow.
uh, and he was curious just about the mechanical properties. So he printed these test objects for me. Actually, the video will be published tomorrow. This is the last day of the creep test, because this one is the longest. Everything else is tested already. The video is
Cool.
almost finished. Only tomorrow morning I will measure these test objects, and tomorrow afternoon it will be published.
I'm jealous of your process that you can finish the testing and project, and then the video can just come out the same day. Like, once I finish a project, it's at least a week before the video gets uploaded, sometimes more.
Because I'm continuously working on video editing too.
Right.
Yes. What is the hardest actually in this case, that I always have at least 5, 6, 7 projects I'm
Right.
working parallelly.
Right.
So
Yeah.
that's a little bit hard, to pay attention when I'm using the same camera. I have 2 or 3 but when I'm using the same camera, because one is actually good quality and it is able to record in 4K, then I have to pay attention what footage should be used where.
Which
And don't
card? And yeah, I have the same problem.
yes, don't delete the old footage which I didn't copy it yet to my computer, and
Yeah.
so
Yeah, it's a real problem. I'm also surprised. I know we're coming up on time because you have a family obligation, but I'm surprised to hear you say that out of all the materials you test and all you use, PETG is still your go-to material. It's surprising.
yes, I from that reason I don't really like the PLA, that even if I transfer it somewhere and I forget it in my car, and it will
Right.
deform even on a Hungarian summer. It's we don't have so high temperatures here, but it definitely it will deform. The PETG will survive this temperature, and it's easier for printing. Even the regular PETG, I like to print with regular PETG. I'm not sure why you have problems.
Humidity.
Right.
But I will say, in my recent tests, I expected it to do poorly, and I then realized that not all PETG is equal. And first of all, Polymaker, Prusament, they make a really high quality product that I think has some additive in it that makes it less hygroscopic. But I think a lot of my negative experiences were with worse quality filament back in the day. But it's seasonal, right? I did those tests around drying in the winter in Israel, where we only have 60% humidity, whereas normally in the rest of the year it's
How far are you
75%.
from the sea?
10-minute walk, maybe.
Oh, uh-huh.
Yeah.
Now I understand it.
PETG is like useless. I have a friend who's from Moscow, and he was like, yeah, I used to print PETG when I lived in Russia. Here I don't bother, and I find the same to be true. But I've had better experiences recently. So
Mm-hmm.
I think it also depends like what you're trying to achieve, Like I'm not printing a lot of stuff that needs impact resistance. What I
Mm-hmm.
care about, especially because I'm printing organizers and backgrounds and things for my set,
There is a
I want.
funny thing.
Mhm.
Sorry.
Go ahead. Go ahead.
There is a funny thing where it's misunderstanding. People think that PETG is tougher compared to the PLA.
Hmm.
According to my measurings, the average values I tested now almost, I don't know, 150 or 200 filaments, which are in my summary table, for my Patreon supporters. And if I calculate the average PLA and PETG impact resistance, the PLA is 2 times stronger compared to the PETG.
Right.
Only the misunderstanding is that the PETG, if you start, you can bend it a little bit, and it
Right.
will break later. The PLA will break suddenly, but for that you need a higher energy. I want to
Right.
investigate a little bit deeper, maybe to explain it in a separate video, because this is really confusing to
Yeah,
many
and
users.
that would be fascinating. And I know a lot of people in the chat also don't miss any of your videos. I recently got to play with 3D Fuel, sponsored my last video, and they sent over PCTG, and that was interesting. I don't know if you've played with that, but it's like they claim it's 9 times tougher than PETG. No, wait, that was something else. It's tougher than PETG and absorbs less moisture.
Mhm. I tested 2 PCTG materials so far, but on old printers, I mean on bed slingers. I want to test again on Bambo Lab or some faster printers now with some better profiles, because I had quite bad experience with PCTG filaments
Oh,
at
interesting.
that time.
Interesting.
But I think the profile should be tuned or something like that. Actually, I did these 2 tests when it was quite new on the market, and maybe the companies didn't have enough experience at that time. I'm not sure.
That's been
Maybe
my
profiles
takeaway
are
as well.
inside that.
Like in all of this little amount of testing that I've done, but in like the last few years, even though, by the way, there are not that many filament manufacturers in the world, like there's only 5 as I know it. I've only been able to ever confirm that there are 5 companies in all of China that make their own filament. There's more in Europe, there's a lot, and there's obviously a lot in the US, but you know, PLA is not just PLA. Like there's PLA Pros and there's PLAs with all different kinds of additives.
Plus,
Even PETG is not just PETG. Even ABS, and you have a lot of companies. I personally use a lot of Polymaker. If Polymaker tells you it's ABS, it's not, probably not. I don't know. I'm not a material scientist, but it's probably not going to behave like pure ABS, because they're a team full of polymer scientists, and they've done a lot of work to optimize all their formulas, and they behave a little bit differently, and their PETG behaves a little bit differently, and their PLAs. So you can't
mhm.
make these like blanket statements like, oh, PETG is really, this or that. It's like, well, which brand and what's actually in it? And yeah. In any case, Dr. Igor, I know you need to go attend to your family, but I do want to give you an opportunity. Where can people check you out? Let's make sure that they know about all the different places that you're uploading content. as well as your Patreon.
Yes, it's My Tech Fun is the name of the. Somebody wrote My Fun Tech. No, it is My Tech Fun.
My Tech Fun. And there are links in the description. If you're watching this on Spotify, we should have links down there as well. And yeah, thank you so much for your time. I really appreciate it. And I look forward to the next video. I think I'm making a cameo in your next video as well.
Not next, but soon, yes.
An upcoming video. Well, in any case, thanks so much. And I hope you'll come back another time.
Thank you for inviting me.
All right. Take care, everyone.
Thanks for tuning in to the Infill Podcast. For show notes or links to anything mentioned in today's episode, visit thenextlayer.com. If you enjoyed the episode, please don't forget to leave us a review wherever you're listening, or click the like button to let us know, and consider subscribing to The Next Layer on YouTube so you can tune in live and participate in the next conversation. We'll see you on The Next Layer.